Welcome to the Phenomenological Alliance channel. In this video, we will provide a practical example demonstrating how better understanding of the human constitution leads to a better understanding of natural phenomena.
The question of whether motion is relative is a very old question. An external observer can notice that the apparent speed of an object changes depending on the movement of the reference point. As early as the 14th century, the French philosopher Jean Buridan stated,
"If anyone is moved in a ship and he imagines that he is at rest, then, should he see another ship which is truly at rest, it will appear to him that the other ship is moving. This is so because his eye would be completely in the same relationship to the other ship regardless of whether his own ship is at rest and the other moved or the contrary situation prevailed."
Since speed is measured by changes in distance, which is fundamentally linked to the concept of space, the question of the relativity of speed naturally leads to questions about the relativity of space itself. Subsequently, there will be many discussions about whether motion and space are relative or absolute, and various arguments and experiments will be cited that support one or the other opinion. In an experiment with a rotating bucket of water, Newton noticed that as the bucket rotates, the surface of the water curves. The concave shape of the water indicates that the water is rotating, although the water is at rest relative to the pail. This implies that the reference point for motion cannot be found within moving objects, but rather in outer space. Newton proposed that space must be absolute, independent of any external reference frame. Space is essentially perceived as a container with fixed and immutable dimensions. Later, with the acceptance of the idea that motion is always relative, the concept of absolute space was abandoned. Einstein's theory of relativity is based on the axiom that different observers can have different measurements of space and time, depending on their relative motion. Basically, the dimensions of space are not fixed, but depend on motion.
Let's investigate phenomenologically with which senses we perceive the phenomena of motion. By examining this question, we easily conclude that the phenomena of motion are perceived by two senses, the sense of vision and the sense of balance. We perceive the motion of the external body using the sense of vision when we compare the motion of the body to the comparison point. Through the sense of vision, we perceive a change in distance. But when we become real participants in the motion, then we begin to experience the additional aspect of motion by perception with an additional sense. Specifically, during motion, we experience changes in speed through our sense of balance. When we are in motion, we perceive every acceleration, braking, or change of direction as a disturbance of balance. It's important to note that while the sense of vision allows us to perceive the motion of external objects, the sense of balance enables us to feel our own state of imbalance, not the imbalance of external objects. Practically, we perceive the speed of an object with the sense of vision, and our change of speed, that is, acceleration, through the sense of balance.
The phenomenological insights into the functioning of human senses indicate that when we observe motion, as external observers, perceiving changes in the relative positions of an object, it becomes irrelevant which object is in motion. In each instance, there is a change in the distance between the object and the reference point. In this context, the relativism of motion is justified. However, when we want to arrive at some destination, then we certainly do care whether we are in a moving sailboat, or we are just watching a sailboat that is being moved. We can get seasick only when we are in a moving sailboat. In other words, when we are actual participants of motion, when we experience motion through the effect of force, as a disorder of balance, then the absolutism of motion is completely justified. It defies common sense to think that it's irrelevant whether we are running while the ground beneath our feet is at rest, or we are staying still while the ground beneath our feet is slipping away. Based on the difference in the experience of forces through different senses, three main branches of mechanics were developed. Statics describes the pressure forces that we experience through the sense of touch and that occur in a state of rest. Kinematics, which describes motion through the sense of sight, without consideration of force as the cause of motion. Dynamics, which describes motion through the sense of balance, considering force as the cause of motion. Essentially, the notion of absolute space originates from perceiving distance through the sense of sight. Conversely, the idea of relative space acknowledges that motion, perceived visually, relies on a reference point. However, the relativistic understanding of space fails to acknowledge that participants in motion, sensing their movement through imbalance, do not necessarily require an external reference point to detect their motion. While different observers can have varying measurements of space based on their relative motion, participants in motion, using their sense of balance, perceive their own change in the speed of motion independently of the external reference point. Even without delving deeper into Einstein's axiom, it becomes evident that the relativistic principle applies primarily to observers rather than active participants in motion.